Okay, hi, this is Lees doing the 2016 SQA National 5 Mathematics Paper 2, and now we're going to do question 9 to 16. Okay, question 9. Express x squared plus ax takes 7 in the form x plus a squared plus b. Now, you probably have a quicker way of doing this, okay, but this is the way that I'm going to do it this time, okay? It explains all the steps, that's the reason I'm doing it. Now, x plus a squared plus b means x plus a times x plus a. Multiply that out in the way I've done it before. X times x plus a times x plus a gives you x squared plus ax plus a squared plus b. Tidy it up a bit, you've got x squared plus 2ax plus a squared plus b. There we have it there. Okay, and I'm just going to write below what you have to compare it to. X squared plus 8x takes 7. Now, comparing things, 2a has to be 8 or it just won't work. Okay, 2a has to be 8, so a would have to be 4. Looking at the very end here, a squared plus b has to be minus 7. We now know what a is, it's 4, so 4 squared plus b is minus 7, 16 plus b is minus 7, so minus 7, put it over, take 16 is minus 23. So, squeezing that in here, you've got x squared plus ax take 7 is x plus 4 squared take 23. Okay, and that's one way of doing it. Question 10. Simplify n squared cubed times n to the power of minus 10. Okay, over here is just a quick summary of the rules for indices that you will need for this sum. X to the power of a to the power of b is x to the a times b. X to the a times x to the power of b, is x to the power of a plus b. And x to the minus a is 1 over x to the power of positive a. All of these will come into play doing the sum, and here's the first one. N squared cubed is n to the 3 2's is 6. N to the 6 times n to the minus 10 is n to the power of 6 add minus 10. That's using this rule here. So that's n to the power of minus 4. And the very last rule, n to the power of minus 4 is 1 over n to the power of positive 4. Okay, question 11. Okay, two pictures are mathematically similar. The cost of each picture is proportional to its area. The large picture costs $13.75. Find the cost of the small picture. Okay. Now there's a few ways to do these. This is the way I would do it. The scale factor. I almost always do the scale factor as the bigger number over the smaller number. Sometimes it's not the best, but most of the times I find it is. The scale factor is 100 over 60, and your calculator, or you, would simplify that to just 5 over 3. The area factor is the scale factor squared, okay, so hopefully you know that. Now that's 5 over 3 squared. Calculator, or hopefully you just square 5, you just square 3, that gives you 25 over 9, which is, as a decimal, the rather, not too great, 2.7777, okay. Now what does that mean? Because they're proportional to the area, the cost of the large picture is 25 over 9, not the best fraction in the world, times the cost of the small picture. The large picture is 1375 is, just replacing things, 25 over 9 times the cost of the small picture. So the cost of the small picture is 1375 divided by 25 over 9, and your calculator would tell you that's £4.95. Okay. And on to question 12, which is a changing subject of a formula. Quite a difficult one this year. Okay, so L is the square root of 4kt take p, and they want the subject changed to k. So you want to get rid of everything here in a mathematical manner and be left with k alone on this side. Okay, first thing we want to do is get rid of that square root. We do that by squaring both sides. L squared, there we have it there, and squaring this just gets rid of the square root sign. The next thing we want to do is to get rid of anything that's adding or subtracting to the I keep on saying the blob, the stuff here that's got k in it. So move it over, change the sign, so we have L squared plus P equals 4kt. Okay, maybe an unnecessary line, just switching these round, 4t times k, but there we have it there, the 4t, where we have these things here, where it's all in one big mass, that just goes down to the bottom. So we have L squared plus P over 4t is k, and that's it there. Question 13, okay, we have express 3 over x take 2 plus 5 over x plus 1 as a fraction, as a single fraction in its simplest forms. Incidentally, x is not allowed to be 2 because 2 take 2 gives nothing, and you're not allowed to have 0 in the bottom. And x is not allowed to be minus 1 for the same reason over here. So we can just kind of ignore that, it's just information that you probably don't need, to be honest. As a fraction in its simplest form. So here we have it here, 3 over x take 2 plus 5 over x plus 1. Okay, the very standard way of doing this is that you multiply this fraction, top and bottom, by x plus 1. So you write x plus 1 there and x plus 1 there. Plus, and you write this fraction, top and bottom, multiplied by x take 2. So x take 2 gets written there and down here. Okay, so we can see that we now have the same denominator or a common denominator. So we can simplify it to 3 times x plus 1 plus 5 times x take 2 over what is now a common denominator. Multiplying out things upstairs, 3x plus 3 plus 5x take 10, tidy it up, gives you 8x take 7 over x take 2, x plus 1, and there we have it there. 8x take 7 over x take 2, x plus 1. Okay, and on to question 14. Solve the equation 2 times the tan of x plus 5 equals minus 4. So, a bit of a toughie this one. Okay, let's whittle this down to what tan x is. So we'll move the plus 5 over to become a take 5. Minus 4 take 5 is minus 9. So 2 tan x is minus 9. So tan x is minus 9 over 2, which is minus 4.5. Now, I'm going to do this in a couple of ways. Hopefully one of these will resonate with you. Okay, first of all is doing this thing called the cast diagram. You might call it something else. First of all, tan is negative. Now where would I expect my solutions to be? Well, tan is positive there and there, and I've forgotten to put in the numbers that go around here. I'll put them in right now. Okay, tan is positive there and there, so by default it's negative there and there. So I'd expect a solution between 90 and 180 and another solution between 270 and 360. Okay, so do a shift tan of minus 4.5, you get minus 77.5. Now a minus angle is dropping that way clockwise from that line there. So there's your 77.5 and then your 77.5 up from there. Now the two angles you want are this angle here and this big angle here. So this angle here is 180 take 77.5, which is 102.5, and this angle here is a complete turn, take away 77.5, which is 282.5. Okay. Or here's another way, this is the other way to do it. We still have tan x to be minus 4.5, can't get away from that. Maybe you did it by drawing the tan curve. Now there's a tan curve there, asymptote at 90, down there, 180. There we have it. We would, okay, so do your shift tan of minus 4.5 and you get minus 77.5. It gives you an angle of minus 77.5. Now the calculators are programmed to give you the answer that's closest to 0. So minus 77.5 is 77.5 over here, and remember this diagram just continues there, so there's minus 90 there, so and there's minus 77.5. okay, now down we go there's minus 4.5. Now if I just extend this line along, there's a corresponding bit there, and there's a corresponding bit there. Now where are these? Well, if you're 77.5 back from there, you're 77.5 back from there, and you're 77.5 back from there to get the x coordinate of there. So we're still going to be doing the same sum. 180 take away 77.5, there's your 102.5, and 360 take away 77.5 is 282. So I'm hopeful that one of these solutions helped. Okay, and on to number 15. Okay, now I should point out that 15 and 16 are quite simple. Okay, so they're really quite, so a good lesson is just to keep on going through an exam, because the ones at the end may not be as difficult as you think. Okay, this perfume bottle has a label in the shape of part of a circle. Okay, and you can see it there, and this is a kind of enlarged version of it. The centre of the circle is 0, the radius is 6.6, the chord A to B is 9, dropping a line down makes that 4.5, half of 9, and there's a radius, as I mentioned to you earlier on. And you have to find the height of the label. Okay, well the height of the label is from there down to there. It's just taking this line here over to here. Now that is 6.6 from the centre to the circle. So from the centre to the circle is another 6.6. So that is the same as that. There's the 4.5 I alluded to earlier on. And as you can see here, this is just a very simple Pythagoras, and you have a calculator. So x squared is 6.6 squared, take away 4.5 squared. Use your calculator, 23.31. And there we have x to ultimately be 4.8. So the height of the label is the 6.6 plus the 4.8, and you get the calculator out, and it's 11.4 centimetres. Okay, I said about the last two were really quite easy. Question 16. You have a triangle there, ABC. 3 and 3 make 6, 4 and 6 make 10, and you have to get the length of BC. Okay, so you have the length of BC, so that is A there, opposite big A there. Okay, so two sides, we want that angle, and that will allow us to use the cosine rule. Okay, now look at this here. We have a right angle triangle, so we can actually use Nat 4 SOHCAHTOA to get that one. The cos is adjacent over hypotenuse, so that's 3 over 4. Do a shift cos, and you get 41.4 degrees. So we are left with a situation where we have a line of length 6, a line of length 10, with an angle of 41.4 degrees there. Okay, so you might want to look at the formula sheet to remind yourself what the cosine rule was, but there we have it there. So a squared is 6 squared plus 10 squared minus 2 times 6 times 10 times cos 41.4. So put that in your calculator, hopefully very carefully, and you get 45.987. Square root that, and you get 6.781. And I've just chosen to round it off to 6.8 to 1 decimal place. Not chosen to, I did it because I was told to there. Okay, and that's the end of the question paper.